Hello, welcome to the video. In this lesson, we're going to be looking at section 1.4, where we're going to be solving linear systems. More specifically, we're going to be solving linear systems with three unknowns. All right. So since we're going to be looking at systems that have three unknowns, we need three equations in order to solve them, which means is we are going to get what is called an ordered triple. So your answers are going to be as followed in x, comma, y, comma, z form. Okay? Just like systems of linear equations where you had just two unknowns, you can get an intersection at exactly one point, x, y, and z. You can get a situation where there's no solution, and you can get a situation where you can have infinitely many solutions. And I'll show you all those different scenarios um, in this lesson. So, first things first, we have our um, system. So we have three equations. We need three equations because we have three unknowns. We don't know what x is, we don't know what y is, and we don't know what z is. So the very first thing that you need to do is you need to choose a variable that you are going to cancel out. All right. In reality, it really doesn't matter. So it's just a matter of look, picking one. There's a possibility that one is easier to cancel out more than others. But looking at this one, you know, maybe not really. I would say probably the easiest one to cancel out would probably be the y because there's a y to the first power here. So let's do that. So let's say that um, we're going to cancel out y and I'm going to use the third equation in both scenarios. So I'm going to look at 2x minus 3y plus 5z is equal to negative 7. Now to get rid of y in this new equation, what I'm going to do in this second scenario, I'm going to multiply this entire equation by a negative 3. So when I do that, I get negative 18x plus 3y minus 12z is equal to positive 9. So what happens is this gets canceled and I combine everything else that doesn't get canceled. So now I get negative 16x minus 7z is equal to 2. All right. All right. So now looking at the next one. So since I used this equation with this equation, what I'm going to do now is I'm going to now look at this equation here. So I'm just going to rewrite 4x plus 2y plus 3z is equal to 12. And now I'm going to multiply this one here by just a positive 2 because I want to get it to be negative 2y. So now this turns into 12x minus 2y plus 8z is equal to negative 6. Cancel this out. This turns into what? 16x plus 11z is equal to 6. All right, so now I'm going to look at these two equations. And I get to choose to eliminate another variable. And it doesn't always happen this way, but it just so happens that I have opposite coefficients of positive 16 and negative 16. So I don't have to do anything. So now I can just say, oh, I'm just going to transfer this over and say, oh, this is just 16x plus 11z is equal to 6. This gets canceled, so now I have, looks like what, 4z is equal to 8. Z will be 2. All right, so I got one variable. I got z is 2. All right, so now what I'm going to do is I am going to substitute in 2 into this equation here. So now I got 16x plus 11 times 2, which is 22, and that is going to equal to 6. So I got 16x is going to be equal to 6 minus 22, which is negative 16. Divide everything by 16. X is equal to negative 1. So now I have X, I have Z, I got to finish up with Y. All right, so probably the easiest one to look at would be this equation here. So with that in mind, I'm going to say that 6 times by negative 1 is negative 6 minus Y plus 4 times 2, which is 8, is equal to negative 3. So just bring this over here. Combining like terms, I get negative Y plus 2 is equal to negative 3. Subtracting 2 from both sides, I get negative Y is equal to negative 5, and Y is 5. So now I have all three uh, unknowns known. So now my ordered triple is going to be as followed as negative 1 is X, 5 is Y, and 2 is Z. Looking at another problem here, again, same idea. What you need to do is you need to choose two values that you could easily cancel. So in this particular scenario, I see like I got a y and a y right here in equations 1 and equations 3. So just by looking at that, what I'm going to do is I'm just going to write in 4x plus y minus 3z. I'm going to leave that alone. And what I'm going to do here is I'm going to multiply this one by negative 1 so I can get rid of the y. All right. This one is going to now be negative x minus y minus z is equal to negative 2. So now when I do that, this y will be canceled, and then this turns into 3x minus 4z is equal to negative 8. Okay, so since I got rid of y here, I'm going to try to get rid of y in this one. So now I'm just going to rewrite 5x plus 5y plus 5z is equal to 3. And again, this one here, you're going to multiply it by negative 5 because I want it to be negative 5y. So here it becomes negative 5x minus 5y minus 5z is equal to, what, a negative 10. And what I notice here is this will cancel, this will cancel, and this will cancel. So since everything cancels on the left side, it's actually going to be 0. And on the right-hand side, it's 3 minus 10, which is negative 7. Does 0 equal negative 7? The answer is no, this is false. Since it is false, this is a situation where I have no solution. All right. Looking at this particular system, same idea. We're canceling things out. Right off the bat, I see that these z is already opposite, so I'm like, all right, let's cancel that. So I don't have to do anything to equations 1 and equations 2 to eliminate z. So I'm just going to write it x minus y plus z is equal to negative 3, and then this is x minus y minus z is equal to negative 3. So this already cancels out. Now I have 2x minus 2y is equal to negative 6. So now here, I'm going to pick, since it doesn't matter, so I'm going to pick, looks like these two as my as my values here for z to eliminate. So now when I go here, because I don't have to do anything again, so this is going to be 5x minus 5y plus z is equal to negative 15. And then this is going to be x minus 5y minus z is equal to negative 3. So this gets canceled with z, and then this turns into 6x minus 6y is equal to a negative 18. So looking at these two equations here and here, all right, I guess one doesn't make any difference. So let's just say I try to get rid of x. So in order to get rid of x, I got to take this equation and multiply it by a negative 3, because it's going to give me negative 6. Negative 3 times 2 is negative 6x. Negative 3 times, so this is going to be now positive 6y, and this is going to be equal to positive 18. Well, what happens here is this cancels, this also cancels, so everything on the left-hand side is 0, but negative 18 plus 18 is also 0. Does 0 equal 0? Yes. This is a true statement. So since we have a true statement with no variables left over, we have a situation where we have infinitely many solutions. So I gave you an example where you do get an ordered pair. I showed you an example where you get no solution. And in this example, you get an example of infinitely many solutions. And that is being able to solve linear systems. Hope this helps. Until next time.